Hello students, now we are again going to solve one more problem from IIT JAM 2021, and this is again problem from mechanics. And in this problem we have to calculate what is the radial part of acceleration in a polar coordinate. So obviously if you remember the formula, if you remember the all formula, then it's quite easy for you, but it's quite easy to derive all this formula also. So how we can derive this thing? This is a very simple stuff. So obviously this is my x and this is my y. Suppose some particle is moving on this particular plane in xy plane. So obviously this is my r cap direction and this is my theta cap direction. This angle is theta. This is direction of r cap. And we also know what will be the radial velocity. The radial velocity is r dot and the tangential velocity is r theta dot. So if we are going to write my velocity vector, and that velocity vector is r dot in r cap direction plus r theta dot in theta cap direction. And we should also know the fact that if we are going to calculate dr cap upon dt, then this value is equal to theta dot theta cap, and if we are going to calculate d theta cap upon dt, then this value is minus theta dot r cap. So these two things we have to remember, and you can also derive it, but for the examination at least you should remember this basic concept. And once we are going to derive this particular thing, let's try to go for the value of acceleration. So acceleration is nothing but dv upon dt, and this is a vector quantity. So I have r double dot r cap plus r dot dr cap upon dt, plus we have three thing here, r theta dot theta cap. So dr upon dt theta dot plus d theta dot upon dt, and and we can take theta cap here, plus we can go for r d theta dot upon dt theta cap, and next part is what, r theta dot d theta cap upon dt. Now we know what is dr cap upon dt, so we can easily put that is theta dot theta cap here. So I can write this whole thing as r double dot r cap plus r dot theta cap, dr cap upon dt I am replacing here. This will be again r dot theta cap, plus this thing is all about r theta double dot theta cap. So this is theta double dot, and next thing is just d theta cap upon dt is minus theta dot r cap. So this will be minus, you have r theta dot square r cap. So what I will do, I will just collect the coefficient of r cap and theta cap on both sides. So what we will get r double dot minus this particular thing, so minus r theta dot square, and this is in r cap direction, and these two things are same. And here is one more thing. So for the theta cap coefficient, we can go for r theta double dot plus 2 r dot theta cap. So I have acceleration, and this acceleration a is nothing ar into r cap plus a theta in theta cap direction. So in the examination we have to calculate, or we have to find the value of radial part of acceleration. So when we are going to calculate the radial part of acceleration, then this is the value. So this value is r double dot minus r theta dot square, and this is nothing but AR. And this is very interesting. So this is final answer for the problem. And we should recognize all other thing also. So what is this value? So this is nothing but centrifugal force is there. There is this value is nothing but the Coriolis force. So you have to analyze this all thing. In this examination they have asked all about AR. In next examination they can give you what will be your theta, what will be a theta, or some another problem, just some r is function of t or theta can be function of t, and then you have to calculate all this thing. So derivation of this particular problem is very important. In spite of remembering the formula, if you are even not going to remember this formula, you can derive it very easily. But if you are going to remember this one, then it's a cakewalk for you. Thank you.